So one thing on the naming issue, apparently CScript.exe is also a command line version of the Windows script host that provides command line options for setting script properties. Neglected to actually Google what I named my thing.
Of course, everyone knew that and were immediately confused.
So I didn't Google the name, but I did actually Google the concept of like the C interpreter in JavaScript. And it's sort of been done a couple times, which I'll talk about at the end of my talk, but for the most part it hasn't been done. So what is CScript? It's more what it intends to be. It'll be an educational tool for learning programming in C, and a mostly specification-compliant implementation of C in JavaScript. And I like compilers, interpreters, type systems, that sort of thing. So a large part is for me to learn JavaScript and to like write a real-world compiler. Now, why do I want to do this? Like the past year, there's been a lot of push to like online, like universities and online like education, especially computer science. There's already things like tryruby.org where you can go and like work through like a bunch of tutorials and start to learn the basics of Ruby. There's also Code Academy, which has JavaScript, like jQuery, and now some Python stuff. But there's nothing for learning C interactively. So, but I need, well, I mentioned this last time. I don't really work at Bartlett. I volunteer at Bartlett, helping out with their robotics team. And for their competition, we use a programming language called Robot C, which is mostly C with a couple additions, which they're like moving towards a more specification-compliant version of C, but it's still not quite C, and the IDE sucks. So if I want to teach them like actual C, and of course like the school district runs on basically all Windows, and I mostly do all of my stuff on Mac. So I have to either deal with platform differences and try to install like good new emulators and stuff, or like teach the Visual Studio, which I don't even know, or do the not really easier thing and build an interactive tool like to teach them C. So that's the road that I've started to take. And okay, so what do we need to build like a compiler interpreter? We need to like lex and parse the grammar, and after that, like one way of like compiling language is to like desugar down to like a core language, and then like interpret that or compile like a much smaller language than like your source syntax. So today I'm going to talk about probably parser generators. I have CFG versus PEG here. CFG stands for context-free grammars, and I don't literally mean context-free grammars. I mean mostly the sense of like parser generators like Bison and things that do like bottom-up, like LALR parsing and stuff like that. Versus PEG, which is parsing expression grammars. And I mentioned JSON versus PEG.js, which are respectively like JavaScript implementation of Bison and a JavaScript implementation of like a parsing expression grammar parser generator. Continuations are like, they're a control flow thing, which I still don't fully understand, but they use a lot of compiling like functional languages. Like a lot of scheme implementations compile from scheme to C by continuation passing style. There's a book called Compiling with Continuations, which is why I've like stressed out for this, which is like the foundation of a lot of the work on using CPS as an intermediate language. And the CESK machine is an abstract machine that uses a control, an environment, a store, and a continuation to like step through and like build interpreters and stuff. And then at the end I want to talk a little bit about like whether I should end up doing a compiler and an interpreter. I haven't really decided yet. I'm still like halfway through the parser for. So.
I like the idea of interpreting C. That sounds fun.
Okay, so for parser generators, options for context-free grammars. These are all tools like Bison or Yak. Bison is the replacement to Yak, and JSON is the JavaScript implementation of Bison. Happy is a Haskell implementation of Yak, and the parsing expression grammars, PEG.js is like a standard JavaScript implementation, and Happy is again a Haskell implementation. so syntax-wise, what typical context-free grammar syntax looks like, it's Bacchus-Fenauer form, looks like that. You've got like a non-terminal, and then the context-free grammar is parsing done basically by like rewrites. So like an assign expert is either a conditional expert or it's a unary expert followed by an assignment operator and an assignment expression. And what this would look like in a parsing expression grammar is basically the same except we've replaced like the or with a slash. Because parsing expression grammars don't do like just straightforward choice, there's an ordered choice. So parsing expression grammars will like in order check whether something's a conditional expression. If that fails, then it'll check if it's a unary expression, assignment operator, and assignment expression. So for CFGs versus PEGs, context-free grammars, again, I usually mean like tools, specifically like Bison and YAG, that do bottom-up parsing and LR, LAR algorithms. And with these things, you have to worry a lot about like the ambiguity, because like depending on like your language, it's easy to get expressions that are ambiguous or could generate like multiple different type of parse tree. And also for that kind of parser, you usually need like a prelexed input to deal with like getting rid of spaces, getting rid of all things, just to crunch it down to like the core like symbols that you care about. Parsing expression grammars, on the other hand, are based on like top-down parsing. They run in linear time, but there's a catch to that, which I'll come back later. Well, they parse in linear time via like packrat parsing. A packrat parse which like caches intermediate parse results in like a memo table to avoid like having to recompute things needlessly. They are unambiguous because of ordered choice. Like if I go back a slide. Yeah. It's like in parsing expression grammars, they'll check for a conditional expression first, and then for the second thing, they won't just like shift and reduce like bottom-up parsing will. So if a conditional expression succeeds, it'll never check the other thing. And this is more obvious in like a different example where somebody's like a sub to the other. Parsing expression grammars, you don't need a lexer. These will just work on like a string level. And the problems is like you run into problems with left recursion that like, so I've got an example later, I'll talk about left recursion in a bit. So the good things about a PEG, the ordered choice eliminates ambiguity, so you've got no problems with that. Left recursion can always be eliminated. You might have to do it by hand, but there's also a couple papers out there on one of the websites I give at the end that like specifically talk about this problem about PEGs supporting left recursion. You can actually just like leave a default like failure option in your memo table, and if it fails, you just skip to the next option. So that's a principle, but I don't think it's implemented in PEG.js. Again, linear time parsing in size of your input, and you don't need prelexed input, and the way the C grammar is written, this from the spec that I have is like, it's written in a very top-down fashion, so it's pretty easy to adapt to parsing expression grammar. The bad things is that rule order matters. So in my parser, I do have like a table of things that like are all the reserved keywords in C. So in the actual specification, they're listed, of course, in alphabetical order, so do comes before double. But if you're actually parsing that, and it tries to look for do before double, you're never ever going to match double because it does this ordered choice. So if you come to a point where it's like double x equals 5.0 or something, it'll always match that as do and never get to double. So double has to be listed first in your grammar. Left recursion elimination can be tricky. I've had this issue, and it's not so hard to get rid of it, but like you kind of lose like the semantic meaning of like the left recursion. So if you like move it all to like right recursion, you get a parse tree that builds in the wrong way. So you lose like left associativity of like addition operators, etc. Space use is proportional to the input, which I guess when like top-down parsing was first being like talked about was a bigger problem than it is now, because now we've got like really fast processors and lots of RAM, lots of hard drive space. So it's not such a big deal to take up a lot of space in exchange for like linear parse times. And I can realize that like sometimes like relaxed input would be nice, because then I don't have to worry about like all these keywords and things. Like things are just keywords that should be. I can call if instead of having to like quote it everywhere. And it would make like dealing with identifiers a whole lot easier. Because otherwise you have to like check for, because whenever you're searching for an identifier, you have to make sure it's not a keyword, and then match something that's an identifier. Okay, left recursion. So this is almost straight from the C grammar. So an add expression is a cast expression, or an add expression plus a multi expression, or an add expression minus a multi expression. In a peg, this looks like add expr is a cast expr plus or minus a multi expr like some number of times, 0 or more. It's basically regex syntax, regular expression. Because you have to like, and this works, and this is mostly what I've done, instead of like actually factoring out the left recursion to like a right recursion. But either way, I think I'm gonna run into problems when I have to deal with like keeping the actual semantic meaning of like addition is left associative. Continuations. Okay. Continuations, according to Wikipedia, are an abstract representation of the control state of a program. So again, I'm really interested in programming languages, so in functional languages especially. So basically, this whole project started as like a way of like, what I want to do is take C, like desugar it down to like the bare minimum I need to like express the same programs, but in a more functional way. So like avoiding mutation, or at least avoiding mutation in the exchange for like, there's a global state, and that's all the state there is. So, I don't know, one way of like, continuation is, there's sort of like callbacks, like JavaScript, if you've ever done that. Like if you're waiting for something and then you sort of pass on like a request to some other thing. I don't know, I haven't done one of them. But compiling with continuations works by like, at least for functional languages, it probably works a little bit better. I'm going to see how that turns out with C. That's one of the reasons I wanted to do this project. So the way it works is you desugar like all of your control structures get desugared into either function calls or continuation calls. And then there's a CPS transform that desugars all of that into like just function calls. A CESK machine is again an abstract machine for like implementing languages, for like interpreting like the lambda calculus. And it stands for control, environment, store, and K, I guess is classical in the literature, stands for continuation. And it's one way that we can implement interpreters. I haven't totally decided how I'm going to actually implement my interpreter yet, so these are some of the options I've considered so far. Okay, so compilers versus interpreters. There's a lot of languages, like recently that are compiling to JavaScript. CScript, I think, is the big example that everybody knows about. There's also Elm and Feltey. Elm is a functional reactive language, similar in syntax to Haskell, but probably more semantically like ML. It compiles to like JavaScript and HTML. That's pretty cool. Feltey is semantically and syntactically a subset of Haskell, which compiles to JavaScript. And I had a lot harder time finding interpreters that are written in JavaScript. There's a bunch of like scheme interpreters you can find online that are written in JavaScript. OpenBrowser is an OCaml bytecode interpreter written in JavaScript. JavaScript, of course, is what? Yeah, JavaScript, of course, is interpreted. So challenges that I think I'm going to face, or have already faced with writing this, is there's this huge paradigm shift from like C, a very like imperative language, moving to like JavaScript, which is sort of object-oriented, sort of imperative, sort of functional, or at least has first-class functions. And this issue of like a source language, an intermediate, a target, and an implementation language. And I think like the semantic differences are probably going to be a challenge. like mapping the C semantics on something that's a lot more functional, and still like this compiler versus interpreter issue, which will come at some point, and the C to a functional IL, maybe IL for an intermediate language, maybe forcing like a square peg into a round hole, but we'll see. Similar projects, because I did try and find things that have done this or have done similar things to this in the past. There's mscripting, which compiles LLVM bitcode into JavaScript. If I were to use this, I would still need like something that compiles C to LLVM bitcode, and I want it to like run on the web. So that's probably almost as hard of a project. Then there's Clue, which is not web-based, and was last updated over 4 years ago. And I'm basing like CScript on a newer like C11 draft. So theoretically, Clue could probably be used, but I'm also interested in like the back end, just the writing and compiling projects. So I think it's just a fun thing to do. The future, what have I done so far? I've gotten like a fully written parser with no semantic actions. I also have like a half-written one, which stripped out like the unnecessary things from C, like no type defs, no preprocessor, things that like make C like sort of context sensitive and like really messy. I still need to like build the interpreter, compiler, whatever I'm doing, put all these pieces together, and then eventually, like once I have like the base, the core of C, I guess, working, then I can start dealing with other parts of C. If you're interested in contributing, it's hosted on GitHub. It's all open source. I'd like to hear suggestions, opinions, and I'd like it to become like a good teaching tool. Hopefully if I get it done in time, I'll probably use it like next semester at Bartlett a little bit. And here's some of the references they use, which are just website links. v4.info/packrat is Brian Ford basically invented like packrat parsing and peg grammars. This is all what's come out of him. Like he wrote his like master's thesis at MIT. Is like basically the foundational work on this. Matt Might's blog, he does static analysis at the University of Utah, and a lot of stuff. He's got a lot of posts on continuations and continuation passing style. And altjs.org is like a massive compiled list of like all languages that compile JavaScript. I think that's